Climate change's crux lies in water, with the ocean being pivotal as it covers 70% of the Earth's surface. The ocean plays a crucial role in climate regulation, cooling, oxygen production, and carbon dioxide absorption, mitigating the global climate crisis. Today's oceans have been severely damaged by climate change, with excess carbon dioxide making them hotter, more acidic, and increasingly suffocating. Specifically, excess CO2 has led to a 50.7% decrease in oxygen levels in seawater, a 3.8% decrease in hydrogen, a 67% increase in acidity, and a 60% reduction in salinity, sodium chloride, rapidly deteriorating marine ecosystems and weakening their pollution purification capabilities. CRCS represents a groundbreaking negative carbon technology, directly converting CO2 into hydroxyl ions without the need for capture, storage, or chemical transformation. It processes gases, soils, and water bodies, rivers, lakes, dams, and oceans, boasting extensive scalability, high efficiency, low carbon emissions, low material use, no pollutants, and a high recovery rate. Marine Carbon Removal Conversion Solution. Addressing marine carbon pollution involves tackling four challenging issues that perplex scientists. 1. The vast area of the oceans, 2. Their depth, 3. Tidal movements, and 4. Ocean currents. To effectively address these challenges, which cover 70% of the Earth's surface, a synchronized implementation of three types of installation strategies is essential: fixed site, liquid type, and put-in. 1. Fixed site construction. The blueprint is to deploy CRCS systems along oceanic circulation paths, performing CO2 conversion within effective ranges at fixed points, utilizing natural conveyors, currents, to distribute healthy seawater to surrounding areas. Connecting points into lines and lines into rings form the optimal broad-spectrum CO2 conversion solution. Requirements: internal space larger than 200 times 200 times 180 centimeters, 110 V power, simple ventilation according to ambient temperature, and location within 700 meters from the sea. 2. Liquid type construction. CRCS systems are installed on various medium to large watercraft, including yachts, cruise ships, ocean fishing vessels, cargo ships, or oil platforms, forming a large-scale CO2 conversion network along their routes. This complements the fixed-site ring model for a comprehensive marine carbon pollution conversion solution. Requirements: adaptation to the available space on the watercraft, ranging from 100 times 100 times 100 centimeters to a 20-foot container, 110 V power requirement, simple air conditioning, with ocean-going cargo ships accommodating systems in containers or holds. 3. Put-in. The CRCS zero electricity system is deployed into the ocean to create a checkerboard-patterned resonant effect for CO2e removal and conversion. This system operates without electricity and is capable of functioning in soil and seawater for over 100 years. The deployment depths range from 100 meters to 1,200 meters, with flexibility according to local conditions. The optimal seabed depth for deployment is 1,200 meters, where increasing the density of deployment significantly enhances the carbon pollution removal rate and helps balance the pH levels of seawater. Triple overlay effect. Utilizing a combination of fixed, mobile, and deployment frameworks allows for the synchronous treatment of carbon in the sky, soil, and ocean. This integrated approach leverages ocean currents, shipping routes, and a checkerboard network of bases to create the most comprehensive marine carbon removal and conversion model. The torus field, torus, at the core of this model indicates the matter-energy transmutation pathways and the directional orientation of the field, extending longitudinally, expanding laterally, and radiating outwardly. The effective range of a single system varies with the resonance rates of gases, water, and soil, with effective heights of 7 to 14 kilometers and diameters of 20 to 35 kilometers. Installation scale. The scale of removal and conversion is directly proportional to the number of systems installed. For example, in the South Atlantic, using the minimum standard would require 36 fixed-site installations along the coast, 20 to 30 cargo ships on fixed routes for mobile installations, and 70 to 80 CRCS units for ocean deployment. If resource allocation is a consideration, prioritizing the ocean deployment model could be optimal. Annual effectiveness estimates. For the South Atlantic removal and conversion model, the expected outcomes include a 45 to 55% CO2e removal rate, a 60 to 70% increase in hydroxyl rate, and a 60 to 70% acidity balance rate. These figures are based on calculations by the EQT Marine Carbon Removal Research Team, which is open to conducting physical tests with third-party professional organizations. The health of the oceans directly impacts the Earth's habitability. We must exert our greatest efforts before reaching the critical threshold of extreme climate change, with a key focus on the oceans.